So, we will continue from where we stopped actually. So, we actually last class we are looking at, I was just giving you the concepts of neighborhood. Neighborhood is the smallest unit in urban residential planning, residential unit actually planning unit. So, whole thing was this actually this concept is very good actually if you look at it. This was given by Clarence Perry 1925, which I said in the last class, and this is what constitutes a urban neighborhood planning. Now, inside this neighborhood, the planning for fire protection is important, right. We will come to that sometime later on. For example, street planning. Street planning should be such that one thing, no thoroughfare, no heavy vehicles passing, but there should be provisions for firefighting vehicles. So, this is one issue which will look into it, and the main focal point of such a neighborhood plans were essentially the primary school, because from home the primary school should be about 1/4 of a mile, that was his concept, which would mean around 0.8 kilometers, right, and there should be PS stands for primary school, and children should be able to walk on their own and reach there, and then high school should be about 1 mile, and the workplace or hospital there should be around 3/4 of a mile, 3/4 of an hour travel by highway or roads, that is the thing, and then you have recreation etc. 1.5 hours and so on, family recreation, something of that kind. So, that was the concept of urban planning actually. So, obviously you find them urban plans would, or any planning would include different types of building, what we call as occupancy classes, types of occupancies. So, this is what National Building Code groups them: residential building, group A, educational building, institutional building, assembly building, business, mercantile, industrial, storage, and hazardous, A, B, C, D, E, F, G, H, and then J. I is not there. So, industrial already is G. So, hazardous building. Now, you can see that all kind of functional designs of building, they have some relevance to urban planning itself. It starts from urban planning. For example, design for thermal comfort or energy efficiency. The clustering of building may be good in certain type of climate, while it should be spreaded from one another, because you need a lot of ventilation. Where humidity is high, northeastern states in India, let us say, or coastal areas, humidity is usually high, you will find the buildings are spaced apart, while in Rajasthan or Haryana, those areas you will find they are clustered. So, traditionally, but otherwise also there should be, because mutual shading, etc., etc. So, planning starts from there itself. For noise, you keep noise sources away from noise sensitive areas. So, residential areas are noise sensitive. Traffic, major traffic should be at the periphery, they should not be inside, or industrial zone which actually might generate a lot of noise should be away from the residential zone. Maybe there are buffers inside like green belts and so on. So, urban planning itself, fire provisions or any other planning for that matter, for example, space between two buildings should be at least 6 H for if they are just in sort of facing each other along the wind direction, so that there is no the wind flow around the building, you have sufficient ventilation, wind movement is there, air movement around the building is appropriate. So, these are other aspects. As far as fire is concerned, similar sort of thing. So, sensitive, for example, hazardous buildings can generate fire, and some of those occupancies might be very sensitive to fire. There can be catastrophe, failure, deaths, etc., etc., fatalities. So, you keep the sensitive ones away from the fire, likely fire generating or hazardous buildings. So, zoning is done right away at the urban planning stage. So, National Building Code defines zone 1, zone 2, zone 3, and some of those occupancies will be in zone 1, right, and zone 3 would be somewhere there, and they should be separated out. So this is first part of the planning. This is first part of the planning. The other aspects of planning which I did not tell you, but much. See, the planning actually is done for minimal traffic flow. So supposing this is an activity space room. Activity space means room. For example, in an academic building, it will be classroom, teacher's room, etc., etc. In residential building, this would be possibly living room. The other could be kitchen, and then bedroom, and so on. So the traffic flow between them are very much considered. Traffic flow between various buildings are considered, various spaces are considered, not building, various spaces. In an area, estate planning, you might also try to minimize the traffic flow. Traffic movement should be minimized. That means what? That means number of people multiplied by the number of movement, frequency of their movement in a given period, let us say weekly. In a hospital building, for example, number of times the doctors move, because doctors are paid salary, the nurses move, and even patient movement, though all this, so generally there's a paper in 1967 by White and Elders which talks about computer aided layout planning of single story building. So there the traffic movement is minimized. It's an optimization problem. You can solve it. This is solved by heuristic ways. So basic idea is that you try to make traffic movement minimal. So moving from one classroom to the another, you should not be spending too much of a time, otherwise it's a wastage. Even the teacher should not be spending too much of his or her time from her office or his office to the lecture room and so on. So that's how it is minimized, and this is an optimization problem can be solved. So this is one issue, but the other issue together with that, traffic is one issue, but other issue is nuisance restrictions. For example, in academic institution, workshop would generate noise. Classroom is noise sensitive. So you cannot keep workshop next to the classroom. If you keep, then you have to provide high insulation. Similarly, any within the building, the one which can generate fire should be kept away from one which are fire sensitive. But then generate fire means kitchen can also generate fire. You cannot keep it away from the other spaces in the room. The other constraint comes into picture. So idea is that when there is a nuisance restriction, you try to keep the sensitive one away from generating one. Some activity spaces are both nuisance generating and nuisance intolerant. So such two spaces of similar kind cannot be, those ones cannot be put together. While one which is not sensitive to any kind of nuisance, fire, water, etc., hazard or nuisance, they are not sensitive, neither do they generate, they fit in everywhere. So in planning stage within the building or in urban planning stage, all issues, functional design issues go in, and fire is also one of them, right. So these are activity spaces, as I said, ABCDs are activity spaces, and you can do the optimization of layout planning for minimization of the traffic. For example, I j spaces, I is not equals to g, weighted, some sort of weightage multiplied by their distances, sum total must be minimized with any constraints, those are there. Now this weightages could be simply doctor's salary per week for the number of doctors who will be traveling, right, the frequency, number of travel multiplied by their salary, nurses travel salary, etc., one can devise them in appropriate manner, right, appropriate manner. Okay. So this is general concepts of functional planning, and it applies to all including fire. Keep generating ones away from sensitive areas, that is what I am saying, generating areas away from sensitive areas, that is the basic principle. Okay, I won't discuss too much about general planning, but let us go to the fire back. So fire, as I said, zoning is done, same ideas in urban planning. Within building, we talked about urban planning, then within building for any kind of nuisance. Now in urban planning also, zones ones are residential, educational, institution, assembly, etc., they are more sensitive. And zone 2 business and industrial building except high hazard industrial buildings. Zone 3 are high hazard industrial buildings, storage buildings, and buildings for hazardous use. They should be kept away from each other. You segregate them, do not mix them up together. They are somewhere in between. Some of them can generate, some of them may be even sensitive. to fire. So, they are in between, and you can use green zones, buffer zones, etc., in between also. So, this starts from planning stage, urban planning stage itself. This is what National Building Code gives you: zone 1, zone 2, zone 3. Zone 1 is a sensitive one, zone 3 is could be very hazardous from fire point of view, right. Okay. So, this is one aspect, this is one aspect. The next aspect is planning around a building with respect to fire, right, with respect to fire, right. For example, you must have sufficient space for firefighting vehicle to move about. So, this is your building, this is your building, right, this is your building. The firefighting vehicle must be able to move freely about it, and there must be adequate space for its turning. Their length can be very, length can be, they can vary depending upon the location, the city, fire administration, what kind of vehicle they are. In a small town, it would not have that kind of a bigger vehicle, which will have kind of ladders, articulated ladders. It may not be carrying those, but in bigger towns they would be of those kind. So, whatever is the dimension of that, and they should be able to take turn freely. So, the turning radius should be available for all firefighting vehicles, right, all firefighting vehicles. So, this is one aspect. So, street planning is done that way. So, minimum dimensions are specified, this width, then this d, right. So, this is are the because minimum width required depending upon the L length, depending upon length I must have, depending on length of the vehicle, these widths are provided, so that there is, it can freely take turn, right, and you can expect that during the kind of emergency they are not unlikely to reverse and go around. This is very difficult, it is impossible, because it is a type of emergency also. So, this street planning should have adequate width, adequate turning distances, and National Building Code gives you those values. So, values of L, for values of W and D for various L's, literature also gives you. For example, one of the references which I mentioned is gives you these values actually. I think I have forgotten the name anyway. This mentions, this is there in the reference actually. So, this mentions actually David Egan books. In fact, this diagram is also taken from Egan's book. So, so Egan's book gives you all this kind of diagram for American situations, but National Building Code of India part 4 it gives you these dimensions. Also, this width must be free, no wall, nothing, no even kind of electric poles or anything of that kind, no obstructions. So, free space W, this is also defined, it should be minimum same W. So, it should be absolutely free. Then very important issue is this: while you are doing urban neighborhood planning, you see, you can have what is called a dead end street. This is a public street which is meant for all traffic. All traffic means, say, let us say within the IIT campus, right. Now, there are residential areas, there are some residences are there here. Now, here what we mean by public street is the street which is meant for number of residences, while this is the private street meant for only these 5 houses, right. This is a dead end street. This is a what is called T or hammerhead, and this is what is called a cul-de-sac. You have a roundabout here, and this is what is called a loop street, right. I think this is mentioned here. So, not mentioned here, no, not really. So, this is called dead end road, dead end, T end or hammerhead. This is cul-de-sac, where you have a roundabout, might have a garden in between, and this is loop street. Now, this is no good, this is the poorest. Poor, good, very good, in fact, very good, very good. Why? The firefighting vehicle cannot reverse. So, a dead end street is a problematic thing. But the issue of urban planning of street, there are another issue. It is only not only the fire, the traffic privacy. Traffic privacy. Traffic privacy means this, you should not have traffic thoroughfare through the residential areas or areas where you do not want it. For example, in IT campus you do not want outer traffic to come in. So, there is no thoroughfare. But when you go to few residences also, there should not be, because this is lightly surfaced, and as I said, it should match with the topography as much as possible. So, curved one looks nice, they consume more space. So, when lot are actually set out, streets are also set out simultaneously in an urban area. So, there should, if curvilinear ones looks good, if it matches with the topography a little bit, elevation down, etc., it should match with the topography with least cost. You make curvilinear route, too much of cost would be involved. But when it comes to residential areas, both traffic privacy as well as firefighting provision must be looked into. So, a firefighting vehicle, you do not expect it to reverse this way. Therefore, this is pretty bad, this is not good. But old days you will find that this is there. Let us say in IT campus, some of those places you will find them, there is a dead end road actually. Originally they may have left spaces on this side, no building on this side, spaces on this side, but when later on something was planned, it might have happened, there are spaces, some places you can see in new campus, you will find this is there is a dead end road. So, this is not a good one in case of a fire, but fortunately the houses that abuts onto these roads in IT campus, they are all 2-storied. If the story height is more, then you have more problem related to this. Hammerhead is porous, this is somewhat better, but it will have to reverse. The firefighting vehicle will have to reverse from here. A T, it will go like this, reverse. This is not very good again. So, you do not want reversal. A cul-de-sac is one where if you keep the sufficient radius, it can just take roundabout and turn and come back. So, this is the best, and loop street also same thing. You find them in Delhi in many places. In fact, you find many places you will find some loop streets in the Luton's Delhi, or some places in the New Delhi area you will find them. You also find cul-de-sacs in some of those areas but then they consume more space. Space consumed is slightly lavish planning. So, this is important from firefighting provisions also, from the fire point of view also. While doing urban planning, one must keep them into mind. Next issue is keeping the space around the building. This space, it must be sufficient for ladder. Ladder cannot be vertical, although they are near vertical today, but I need sufficient space. The vehicle will be here, it will actually be, there will be supported on a jig, it will be stationed there, stationary. Then the inclination, if it has to, supposing it has to evacuate people from here. So, taller the building, you need, so W is a function of, you need more space. And one way of controlling this is through what is called floor area ratio. What is floor area ratio? Basically, total floor area divided by the plot area. So, supposing floor area ratio is equals to 1, then plot area is same as floor area, right. So, if it is 2, because we are saying that it can't be more than 1, let us say we are saying floor area ratio is 1, I can't have it more than that will be the. So, when it is for single story building, single story building, right, single story building. For 2-story building, what will be the floor area, floor area of each floor? It will be half. So, taller the building, 1 story it will be like this, 2 story it will be something like this, it will get reduced, 3 story it will get further reduced, because the floor areas, if it is 1, but it is actually given, the values are given. So, putting a restriction on floor area ratio, right, floor space index, floor area ratio, you can ensure that there is sufficient width. Besides that, you define that minimum width required here is this much. Minimum width required around a building is this much. Besides, you can also restrict the floor area ratio. So, floor area ratio is one of the ways of controlling. I mean, among floor area ratio does something more, but it is one of the things because it will also control the density. I just give an example, of Delhi of recent years. The tendency is to increase the floor area ratio, and they have increased it. Earlier, height of the buildings were restricted in many of these areas nearby IIT, say Lajpat Nagar, CR Park. Many of these areas it was restricted. You couldn't have gone beyond a height. Now, the moment it has been actually, it has been liberalized, the negative effect of this is population density has increased, because where one family used to live or two families used to live, now it can three-four, you have increased the story height, FAR both have been actually increased. Perhaps the idea was to have a construction or real estate boom in areas where the land price is very high, because there people will go and purchase. Well, the negative effect of this is, the positive effects is, of course, it has increased possibly initially, but I don't think the real estate is anymore increasing at the moment, current state of affairs. It is not increasing. It's actually, the demand for houses, because the houses, it also gets linked to purchasing power of people. The people who can purchase, they have already got houses or invested in houses. People who can't purchase, they can't purchase anyway. So, those issues are separate, but the point that I am trying to make is, by liberalizing the floor area ratio, what has been done is actually population density has increased, right. By increasing the population density is increased, and says urban areas like Delhi or Mumbai, the moment you do that, the people who occupy, they are affluent people, and many of them can own more than one or two vehicles. And if you are private, public transport system is not very good, which definitely was the case, very bad, in fact was the case till metro started, right. People will have their private vehicles, and every house now, the density of private vehicles have also increased, because the family, they can afford maybe 2 cars, 3 cars a family. You have given them floor area restriction has been liberalized, the population density has increased, car density has increased, traffic is, as you know, all over the country, most of the urban areas, traffic is all, and then pollution is another thing, and construction also adds to the pollution. Anyway, that's, by the way, that's not part of my fire discussion, but this is very important. So, it's not that just like casually people do floor area ratio restriction, there are issues, and that should be looked into before changing it, tinkering with it, or coming at a value, right. Okay. So, this is important, this width is important, and it depends upon the height, because this theta is fixed according to the machine that you have. So, you need this L cos theta value or H cos theta value, height you want to cover, H cos theta value. So, therefore, this will depend upon H simply, right. So, this space is important. Then the second issue is, you obviously provide supply of water to the building, because the National Building Code gives you the amount of water that should be there for firefighting purposes in all kind of occupancies. For each occupancy, there is special requirement, minimum capacity of the tank, water tank that should be in house. For example, if you look at the IIT main building, that is, we did not have a firefighting wet riser or firefighting system, manual firefighting system before. It only started somewhere around 1990s. There was a tank construction, size of such tank, stored water, that is specified in the code, because you need to do the firefighting. But sometime you may not have it in the building itself, it might be provided from somewhere, water supply tank outside. Then you have what is called fire hydrants. Now, these fire hydrants are close to the streets. So, goes to the planning itself, typically around maybe 100 meters within the the spacing is given less than, so if in American standard it would be less than 200 feet, means 60 meters or so on the distances. So, from here the pipeline can connect, this is a Siamese connection through which the pipe goes up. So, in case of tall building, fire hydrant, distance between fire hydrant and where there is a connectivity to, if you have seen block 3, block 4 etc., you will find the fire hoses are there, and there are also, you can see that inlet points are there, and they can be connected to the fire hydrant. They can be connected to the fire hydrant. And similarly, so every building should have, or some buildings, low rise building, you do not need a straightaway the firefighting people can connect a hose from the fire hydrant and spray water to this. So, to provide water for firefighting, you need fire hydrants which are planned close to the street, close to the street. The firefighting machine, they have pumps. Sometimes you might have even in-house pumps through which actually you should be doing. So, this is other thing, planning of fire hydrant should not be more than spacing should not be more than 100 meters, not more than 100 meters. Distance from fire hydrant to the inlet point in the building should not be less than 60 meters typically, but the code gives you those values. The National Building Code gives you these values. So, this is the one thing. Second thing is fire separation. Next thing is fire separation. These are all part of planning. So, what we have looked into so far? We have looked into, one is the street planning, then the spaces around building, floor area ratios, their relevance to fire planning, then the space around the building related to the height. Then we have looked into the fire hydrant, and the street planning also we said that neighborhood planning how there should be, because we said cul-de-sac should be there. A cul-de-sac, it's something like this where firefighting vehicle will come, take turn and go back straight away. I mean, sorry, this should be this is like this, it can come and like it can come and freely. So, that this diameter, it is all given in the code, the values are given in the code. So, accordingly you can, it should be what should even this diameter straight to it minimum, these are all given. Then we looked into the issues related to fire hydrant planning of the fire hydrant, which are the source of water connected to a tank, larger tank, and that can supply water to the building when required. Now, coming to fire separation. Fire separation is defined as the distance of the building from potential fire source. The potential fire source could be another building, because there might be a fire in that building and it will try to spread to this building. So, potential, or maybe an electric pole or anything. So, fire separation is the distance separating two spaces or buildings, we will say two buildings or even electric poles or any other fire source. So, distance separating the building from any fire source. Now, if it is two buildings, then if there is a fire in this one, radiated heat will be radiated through the windows and can reach this one. So, I need higher separation here, otherwise this will spread to this one. So, while doing urban planning, this aspect has to be taken into account, right. And the walls can be designed depending upon the, if the walls are designed in such a manner that the fire cannot enter here, it has got sufficient fire resistance, then it has got sufficient fire resistance. In that case, the spacing can be reduced, fire separation can be reduced. So, for example, here I have a wall, complete barrier, self-supporting barrier, which will act like a wall and will not allow spread of fire. So, the space between these two has got fire separation between these two building is now less, because its effective fire separation is this much. Well, in this case, supposing I have put in some kind of specific frame with a sprinkler system here. So, in case of this gets heated up, it will get cooled. It is a costly system, nobody would possibly doing it, means lot of cost, but the concept is separation concept is important. You may not provide a sprinkler, but some cases they might do also, not in Indian scenario, that is what I am talking of. So, you can reduce down this distance. This distance should be large when there is nothing. If the fire resistance of this wall is high, you can reduce down this distance. If there is a sprinkler system, you can still reduce down this system. If you have a barrier, this distance will be less, and this is no window, and these are fire already fire resistant wall, then this could be very less. So, these are conceptual. These are conceptual. Code gives you the values, but the idea behind the code is these are the ideas, right. So, we will break for here.